Okay, here we go.
And we're live.
And we're live. First of all, we have an egg being created right now. Is it a he or a she? It's a she. We have an egg. Her name is Agatha. And Ava is currently being her creator.
No, I'm
All right.
actually writing what is on the board.
Also writing what's on the board. We are talking about Newton's laws today. Continuing our journey into physics. As I said, also someone apparently has the bird flu. So that's what we've missed so far. And happy Friday Eve.
They died.
No, they didn't.
They did. That's what Miss Essex said.
What?
Unless you want.
Yeah, that's what Miss Essex
This
said.
dude's holding me hostage.
She said, stop. She's
Somebody in Ohio got
Let go.
chicken.
and died.
Yes, they died.
It died, but just
Yes, they died.
Died seems extreme.
They died.
Yeah, but some people have
The chickens died.
The chickens die.
Human died.
Yeah, she did say it.
Can we look this up?
She did say I can.
It's up to you. It's your Agatha. All right. Once again, shh. An object in motion remains in motion, and an object at rest remains at rest unless acted upon. Yes. By an unbalanced force. It has to be an unbalanced. Wow, I can't write.
Is gravity balanced?
Is gravity balanced? No.
No. Nobody gets that.
Because does gravity pull you down if you fall?
Yeah.
Unbalanced force.
Balance.
Right? Made that object. Essentially, we're saying if it's not acted upon, it wants to be. Well, how would you put this in your own words? In your own words, write down right now. In your own words, write it down. Write down in your own words this law. I will grab Agatha while you guys are. Oh, this is beautiful.
Oh, picture.
Do you want to sign it? Or back? Not really.
No credit needed. That's humble. That's why we had her do it. Write this in your own words. These notes are going to be wild to watch later. Why does she have side eye?
Because she's Agatha. She does not have it.
I think CPK could.
Yeah, she ruined. She ruined.
You should do a double sided.
That's
You should
atrocious.
do one of them double
I think she's great.
I don't.
I like her.
It's not that bad, but CPK.
Sorry, I just can't afford 2 eggs in one class.
Just write on the back.
It's a lot of money. A year ago, I could have done like 3. This is my own money I spent on that egg. Eggs are what, like 50 cents an egg now? Maybe more.
They're definitely not.
I bought these at Aldi and it was over $4 a dozen.
I bought a carton of eggs yesterday for $2.
Where?
Get it, Teddy, right eggs.
No, you didn't.
Yeah, it was like it was like $2.30. Yes.
Prove it.
The best place
Prove it.
to find under $1 eggs is back in bed. Keep dreaming.
Okay. Who has own words they want to share? Anybody want to share theirs in their own words, what they said?
I feel threatened.
The car's moving. It'll stay
Hey, Bodie, stop touching him. Joel.
If you're moving, you stay moving. If you're not moving, then you're not moving unless you start moving.
Okay, what else? Who else? Own words. Sarah Beth, what'd you say?
I said schmoovin'.
An object will be in motion until acted upon by an unbalanced force.
Okay. Someone else. Anyone have something kind of? Gavin?
Not like an object moving, will keep moving. Changes it. Stops it.
Do you want to know what mine is?
Katie wants to go. CPK wants to go.
You got one? Okay.
Schmoovin' keeps schmoovin' unless it gets chalked. And chillin' is chillin' unless it gets chalked.
Great.
You don't care, bro.
I do care. I said it was great.
Yeah, but like.
Because it's your own words. If it makes sense to you, that's what matters. My definition in my own words is this. Objects are lazy.
That's basically what I mean.
Agreed? If you're not moving, do you want to move?
No.
No. If you're already moving, do you want to stop?
Yeah.
Yeah.
No. All right? Because you're lazy. So what would be an example of an object in motion that wants to remain in motion?
Earth.
Earth? That'd be good.
Great one.
What else? What's something big
Ocean.
that is in motion that wants to remain in motion?
The atmosphere.
The sun.
Oh, the atmosphere?
The planet's in orbit.
Guys, do you know what would happen if the Earth stopped spinning right now? Have we talked about this?
Flying in like multiple miles per hour.
That's exactly correct. If the Earth stopped spinning, all right, the atmosphere would remain in motion. So unless you are connected to something that's connected to bedrock, you will be just thrown off the planet.
It can't break.
Huh?
Minecraft?
Can bedrock
If you
break?
fall through the bedrock, then you die.
Yeah, you
But
go
you
into the
can't.
void.
Bedrock's unbreakable.
Yeah, but you can't break the
That's
bedrock.
what you actually can't.
I'm just saying, trees, dirt, houses, gone.
We don't play creative.
No, you can like build machines.
So like, what if you're in a cave then?
Yes.
That's a great question. What if the atmosphere stops, but the Earth keeps spinning?
Then we move with the atmosphere, right?
Then
Lots of wind.
the atmosphere would stop, and the Earth keeps spinning. So the thing we're standing on is still moving, right?
Yeah.
So we just have a ton of wind.
You spin.
Would we be able to see? Would we be able to see? Like,
I don't know, actually. I'd have to think about that. That's a good question.
You'll be able to see
Would we just be stuck
So
moving in a
if
constant
the
position because we're
atmosphere's
stuck
around
in the
us, So if
atmosphere?
the Earth is still spinning, yeah,
Right.
we're just moving through the air.
So I guess it would probably, no, here's what would happen. No, here's what would happen. It would feel like you're running into a brick wall at 800 miles an hour.
Oh, I felt it.
So, because think about it. The atmosphere is spinning. If that stops, you spin into it. That would be the opposite.
Oh, yeah, 'cause then
It'd be the opposite. Sorry, my mind was not thinking. What about a train? Right? Once a train's in motion, can a train easily stop? No, it takes like miles, right?
I got one.
Yes.
How about like Andrew Skolka going coast to coast?
Who?
Andrew Skolka.
I don't know who that is.
David Goggins.
I don't know who that is either. Anyways, come up with something and then draw a picture. Come up with something and draw a picture. While I set up our demo. Agatha is about to get crazy.
North America.
So we got the.
Wait, where are we drawing
A picture of your example, whatever your example is.
There's Florida.
I'm drawing Andrea Skolka going coast to coast.
I'm gonna do Jack going coast to coast.
North
Jack
America.
goes coast to coast all the time.
Europe. Antarctica.
Oh, what's it?
Asia. Africa.
Oh, I've seen that.
Yeah, I know you
A little like a bullet count.
What I'm about to do
Will there be egg on the ceiling?
is called the Tower
I've not seen it.
of Doom.
Oh!
Oh.
Is it boom or doom?
Doom.
Wait, I can't see. You bring the boom.
So, what I have here is a paper towel roll. I was going to do this with a toilet paper roll, but don't have one.
Is that what you needed to go
Not
get?
very fun.
Yeah, but this is going to be even more fun.
Yeah.
Agatha, if you can't see her, is going to lay, hopefully not. If Newton's laws work, Agatha should be fine on the top of this paper towel roll.
That's pretty accurate.
All right, now we got to make sure everything is lined up. All right, got to make sure it's lined up.
Ready? Liam Horwood, please.
All right, that's a pan. There's no hole in the pan. It's solid. That looks lined up this way. How's it look from your view?
What's gonna happen?
Does it look like right in the middle? Okay, so what I'm gonna do, I'm gonna hit this pan straight like this. All right? What should the edge of the pan do with the paper towel roll? Should grab it, right? And should hit it pretty quickly. Agatha is an object. Agatha is an object that's lazy, right? Yes? So if this works correctly, I should be able to hit the pan quickly. It should grab the paper towel roll, and Agatha should drop safely into the water below her. What?
You've probably done this, Ed.
I've done this before. Sometimes it works, sometimes it doesn't. All right? But this looks pretty well in line. I'm just saying, from all angles, this looks pretty good.
Put your body on the line.
Okay.
I'm catching Agatha.
What? No, don't. There's no catching her.
If it goes, no, if it.
All right, stay back. Are you ready? So it's going to be count of 3. I'm going to hit it. All right, 1, 2, and then on 3, I'm going to go wham. And we're going to see if Agatha lives.
Please.
You came at the perfect time.
I heard Agatha.
Yes. Yes.
I'm really excited.
So this is Agatha that we love.
Okay.
We have created her. Ava created her. No one, well, a chicken birthed her, technically. I also told him this is my most expensive demo I'm doing this year
Okay.
with the price of eggs.
These
So
are very expensive.
I bought this with my own money. That's how much I care. That's like a 50-cent egg. Are you guys ready?
Pay it back.
I'm ready.
Agatha should remain at what?
Constant speed.
So if everything works, where should she go?
Straight down.
Okay, are you ready?
Might be the dumbest thing I've ever.
Are you gonna count together? Count of 3. Wait, let's start over. Okay, are you ready?
Yeah.
1, 2. She has survived. Agatha, wow, she's got side eye too. She's sassy. Hold on, let's make sure. Hold on, let's check. Let's check. Here, that's the only way to find out. Not even a crack.
Wow.
Made it up.
It's the side eye. It's the side eye. Look at that. She's got attitude.
She looks a little sassy.
I like it. Agatha has survived. Physics still works. Give physics a round of applause. Yes. Did you guys know Mrs. Davis, her dad was a physics teacher. So, pretty cool.
That's so cool.
Yeah, that actually worked really well. I was very, and that was recorded, so you guys can watch that back. Are you on here, Nick? Can it see you? No. So, objects are lazy. Newton's first law. Got it? Flip it to the next page. Thanks for stopping by. That was good timing.
Are we gonna use Agatha again?
Probably not. Agatha survived. I feel like she deserves to have retirement now.
So what are we gonna do with Agatha?
She will become.
Can we bury Agatha?
You know what we should do?
Bury her?
We should put her in vinegar and let the vinegar dissolve the eggshell off slowly. So it's just like the yolk. Have you guys ever seen that?
Let's do
Yeah,
that.
let's do that.
Should we do that? Have you guys ever seen that?
See that part of
Take
it?
it down to the food room.
Oh yeah.
Scanner.
Should we?
We are making eggs today. I could eat her.
I put square.
I could eat
She
Agatha.
doesn't deserve it. She doesn't deserve it.
Here,
No.
guys, I have a story about that. I did that once, all right, where I put it in vinegar, and it takes like a couple weeks. It dissolves the egg, and then I had the egg, and you can pick it up, and it's just like the membrane of the egg, and you can hold it, but like you don't want to hold it. So the egg had disintegrated, and it was just there. And I had this student, his name was Titus.
Titus?
All right, Mr. Worth remembers him many years ago. So he decided to just hit the egg, and he hit that egg, and it just like went like that because it disintegrated, and the smell was horrendous. And that was in my old room that had carpet still.
Wait, I'm confused.
Yes. So Titus broke the egg.
It doesn't check it.
Do you guys want to do it? We could do it.
Water boiler and then
So
microwave.
what I'll do, I'll fill this up with vinegar. Vinegar is a weak acid that will dissolve the outside of this egg.
Good catch, Cheer.
It won't smell as long as we don't pop it.
Wait, Mr. Helen.
And we'll set it over here.
How'd you know that the smell is bad?
I know what stuff should smell like, okay?
But you say you can't.
Everyone else could smell it. Everyone else could smell it.
What if they were just faking it?
What? Trust me.
Or what?
They
what
weren't.
If, what if he is faking?
Do you guys feel happy that she survived? I feel very happy. Even with the side eye. She's got some spice, but that's okay. We like spicy people. Like, spicy's good. One of my daughters is kind of spicy.
Pause.
Spicy, like, little attitude? Yeah.
That's what we thinking.
I haven't laughed yet.
You haven't what? What'd you say, Ava?
Ava just said I was laughing.
Why were you laughing? Just kidding. Hold on. No, we're gonna dissolve her.
Maybe we should grow an egg.
Take off her skin.
Ah, here we go. We got the vinegar. All right, we're gonna set her down.
French fries.
True. All right, here we go.
How much you want?
Just enough to cover.
Vinegar is.
Agatha is taking a vinegar bath.
You know if you drink vinegar, it's good for you?
No, it's definitely straight vinegar.
Yep,
is really good
that's
for
great.
your- They use it to clean like floor.
So,
Yeah, white vinegar.
check this out, guys. The eggshell. This is kind of cool. The eggshell's basic. You can already see the reaction starting to happen.
Yeah, yeah, look at the top.
All right, do you see the bubbles
Yeah, look at the very top.
starting to form?
Blueberry fizz.
All right, you guys see it? So all that should be left in here is a yolk, eventually. It'll take a few days, but look, can you guys see the egg starting to dissolve? That's vinegar. You put vinegar in there.
She's gonna die.
I mean, she's gonna have exfoliation. She's gonna be exfoliated, yes. She's gonna shed to a higher form,
Wait, can we pop it after?
maybe. All right, I'm gonna set Agatha
You know what we should do?
over here. Needs to be somewhere where she can't be disturbed.
We should throw it.
Where can we put her?
No, pop the juice into the balloon.
Here,
Don't knock it over.
Wait, no.
because we can't touch her. We're gonna put her right there.
Put her on the balloon. Yeah.
Look at that, she's bubbling. The balloon?
Yeah.
Is that this class or is that another class? Fourth quarter. It's coming. That's only a couple weeks away. It's crazy. Remember, no prior. I'm just blowing it up, letting it go, right?
Yeah.
Okay.
That is good.
Were you not there for that day?
No, I was, but how are we gonna watch what happened? Because I wouldn't see the reaction.
I know what I'll do.
Set up a camera.
I will hide my phone because we have lunch the period before this. I'll hide my phone on record on 0.5, so you have the largest view of the room, and then I'll record it from like this view because I'm just gonna go like this and let go and then close the door. Yeah. Okay. Yes. Where'd you think we're doing it? No. That's not funny if we let it go in here.
We can just do that anytime.
Yeah, we could do that right now if we wanted to. Okay. We're back. We've been live the whole time. So far we've got like 17 minutes worth of notes for about 2 minutes worth of writing. But that's okay. You guys should see my AP Chem. It gets crazy. I just needed to go up higher. It's not working.
That's like I'm just doing loud.
Why is this not? It should. It's like not.
No joke.
It's fine. It's fine. Newton's second law. Newton's second law. Are you guys on page 2? Yes? Okay. So, page 2. Newton's second law is essentially an equation. So, let's write it in words. So, am I on the screen? Yes. Okay. So, Newton's second law.
I don't know.
Why is that so crooked?
I know.
It's fine. Anybody know it? It says,
Didn't we already learn these?
you have. That's why I'm not going to spend a lot of time on it.
We learned them this year.
No, not this year.
Yeah, we did.
Probably last year. An unbalanced force is equal to the object's mass times its what? Not volume.
Acceleration.
Acceleration. Yes. Times its acceleration. Why does acceleration make sense?
This direction.
Because if there's an unbalanced force, it's going to either speed up or slow down. That makes sense. So if we're going to make this into an equation triangle, we would have F on the top, M and A on the bottom. Let's talk units. Mass measured in what?
Grams.
No longer in physics do we measure in grams.
Milligram.
Bigger. Kilograms. We know what acceleration is measured in from last chapter. Meters per second squared. Meters per second squared. So, what is my unit for force? Newton, Sid? But it's a kilogram times a meter per second squared.
Isn't it just, but isn't Newton?
That is the same thing as a Newton. You were right. All right? A kilogram times a meter per second squared is known as a Newton. So this is a Newton. So we can write 3 versions of this equation. F equals MA, right? I could write A equals what? F over M. F over M. And M would equal F over A. So now, how many equations do we have this semester to solve for acceleration now?
6, 7, 2.
Now we got 2, right? Take a look at your blue sheet. Take a look at your blue sheet. Get the blue sheet out. So on your blue sheet, this is box row 2, column 1, row 2, right? That is column 2, row 2. You guys see it? That is on there. So what's an example of you can think of for this law? Anything moving.
Car.
What?
Car.
A car. Hang gliding. What else? I don't know why I said hang gliding.
Jet skiing.
Jet skiing. Yeah, make an example and draw a picture. All right? Make an example and draw a picture. Make an example and draw a picture.
I'm drawing JC trying to hit that bar down, and then he gets to stop fighting. Wow, I'll lock you.
Make an example, draw a picture.
Right past your front.
I think he's always.
Guys, look at the other paper you picked up on the way in. Take a look at this. Look at number 3. Look at number 3 you picked up on the way in. What do you notice weird on number 3?
Negative newtons.
You have negative newtons. Well, shoot. If I have negative newtons, that means I'm going to get a negative what? Is that possible?
Yes.
Because that means the object is?
Slowing down.
Ah.
But how do you
Okay.
remove the force?
What?
Like how do you remove the force?
The force won't cancel it out. You'll just use the equation triangle. Number 2. Take a look at number 2. Number 2 says I have 60 newtons, which is a force. I have a mass of 150 kilograms. Watch out for conversions. Okay? So, if it's in grams, it has to be kilograms. If it's not in the right units, you're going to have to convert it. What's the acceleration? 3-line method. A equals F over M. Right? Next step. A equals 150. No, that's wrong. 60.0 newtons. This is the 0.0 important. Why? How many sig digs does that have? 3. Yes, man, you guys are good. You guys got it. 60 newtons divided by 150 point kilograms. Does the point matter? How many sig digs? 3.
4.
Because remember, any number greater than 1 with a decimal, everything counts. Everything counts. So, A equals, get out your calculator, Desmos, do it.
Wait, 2 over 5.
0.4.
Whoa.
0.4.
Is it?
Yeah.
It's 0.4.
60 divided by 150.
0.4.
But how many sig digs are in this number?
3.
How many sig digs are in this number? So what am I going to have to write? 0.400 meters per second squared. Am I done?
Direction.
Forward. Down the shaft. All right? Whatever you guys want to say. There has to be a direction. Because acceleration includes a direction. Yes.
Why does 0.40 not work?
Because that only has 2 sig digs.
Wait, does 0 not count?
Remember, for less than 1, it starts at the first non-zero digit. Question. Force needs a direction. Force should include a direction. Your homework tonight is the odds.
Oh.
You got 10 minutes. Get started with a partner if you want to.
Do we have to do the back?
Yes. It's not that many. There's 11 total problems.
We also have to do a lab report.
So that's like 5. The lab report, you can finish that now. It should be 5 minutes.
Hold on, guys. I'm gonna go with my friends.
Yes.
Beginning of class or like end?
Beginning.